Welcome to the first tutorial about the function blocks of the FlexiSoft motion control module Mach1 in the FlexiSoft Designer. This video deals with the function block position by reference. This function block is used for generating an absolute position. Therefore, two different factors are required. A relative position, which comes for example from a sine cos incremental encoder, and a reference signal which is triggered for example by using a reference switch. So let's have a look at the Mach1 logic editor. In the tab function block you can find the various motion in function blocks. By drag and drop you can put it into the main window. At first we focus on the relevant in and outputs. The input motion in expects a relative position which comes from an encoder directly. You can find the encoder under inputs in the cluster Mach1 encoder. Because we want to produce an absolute position out of the sine cos encoder, we have to choose the sine cos encoder and place it in the configuration area. The SSI encoder need not to be used here, because he normally provides an absolute position. Reference enable starts and ends the reference process, and the input reference sets the absolute position to the configured reference position. In this context we have to connect the real inputs. Because the Mach doesn't have the real inputs, we need to route these inputs from the CPU to the Mach. We switch to the CPU logic. There, I have already connected the inputs reference and reference enable to routing end-to-end function block. Now, we have to switch in the left sidebar to outputs, where we take 2 bits and connect it into the outputs. To make it easier, we rename the bits. After that, we switch back to the Mach1 logic. We can find these bits in the tab Inputs and put them via drag and drop into the main area. The output motion out provides the absolute position which is generated and can be used in subsequent function blocks. Reference acknowledge indicates whether the reference function has been set successfully and set the start value for the absolute position. By double-clicking on the function block, the configuration menu opens. In the first tab we have to apply the values which you have defined in the encoder settings before. There you can see the settings of the absolute position range. In our case, we have to activate the periodic position window. That's because in our application, the mechanical position is a periodic position like a mechanical press. There, the beginning and end of the position range are joined to each other. That means, for example, the mechanical position repeats every 360 degrees. This graphic explains the function periodic position. On the horizontal, there is the encoder information. There, you have the possibility to configure the origin as well as the length of the periodic position. In case of a mechanical press, we expect the length of the periodic position is 360 degrees. As you can see, after passing the configured length, the car always is at the defined origin. In the next tab Referencing, you can define the reference position. This is the start value for calculating the absolute position. With the help of the following graphic, I will explain this function. There you can see the relative position at the input motion in. Also, there is a field which shows the absolute position that is generated after referencing. The predefined reference position is shown there. The reference process is started when the signal at the input reference enable is going high. If there is a high signal at the input reference now during an active reference process, then the value for the absolute position is set to the defined start value. In this case, the output reference acknowledge is set to 1 and the function block starts calculating the absolute position internally by using the relative position data at the input motion in. A low signal at the input reference enable terminates the reference process. From this point on, we have a valid signal for the absolute position at the output motion out. The reliability reference signal parameter has to be activated if the signal at the input reference is a reliable signal. If this is the case and the relative position data at the input motion in is reliable too, then the absolute position at the output motion out is also reliable. Let's switch to the next tab, re-referencing. By using the re-reference function, a slip during the movement can be deleted and the absolute position of the function block can be corrected. Therefore, you can define up to 8 re-reference positions in this window. By clicking the plus button, the configuration is saved. Here, you can enter the re-reference position tolerance. Only in this tolerance range, the input re-reference will be accepted and set the position to the relevant re-reference position. Let's have a look at the relevant graphic. There you can see the absolute position at the output motion out, which is calculated by the Mach1, the mechanical position, as well as 3 predefined re-reference positions. The green area shows the range of the defined tolerance. Also, there are optional inputs re-reference enable and re-reference. If the input re-reference enable is high and a rising signal edge occurs at the input re-reference, then the function block checks whether the current absolute position is within one of the configured re-reference ranges. In this case, the absolute position is set to the responsible re-reference position. The reference cycle has to realize once after the power on. Only after the reference cycle the system has an absolute position. That's it so far about the function block position by reference. Now you've got to know the functionality and how to configure the various parameters in the Flexisoft Designer. In the next video we take a closer look at the function block position cross-check.